To discuss about chemical reactions of alkanes. During a reaction, bonds break and form. Existing bonds will break and new bonds will be formed. Right? In hydrocarbons, there are bonds between carbon and carbon and hydrogen. These are covalent bonds. So, in any organic reaction, cleavage and formation of covalent bonds occur. Cleavage means breaking. During any organic reaction, this covalent bond breaking and reformation of covalent bond occurs. There are two types of bond breaking or bond cleavaging. These two ways are heterolytic breaking and homolytic breaking. Heterolytic breaking and homolytic breaking. We'll discuss about heterolytic cleavage. During this heterolytic cleavage, two electrons involved in the bond will be received by a single atom. For example, like this, in hydrocarbon, there are carbon-carbon single bonds in alkanes. So here, except this electron of this carbon, there are three electrons belonging to each carbon atom. Right? When these two electrons involved in this bond are received by a single atom, this carbon atom has only 3 electrons, so it becomes positively charged, and this atom has 5 electrons, so it becomes negatively charged. So in heterolytic cleavage, the 2 electrons involved in the bond will be received by one atom, and these 2 electrons are received by the more electronegative atom. Here in carbon-carbon bonding, both have equal electronegativities. So in such cases, we do not want to consider the more electronegative atom. But in general, these 2 electrons are received by the more electronegative atom. This will result a positively charged cation and a negatively charged anion. You could see that 4 is a valency of carbon and 3 electrons are in one carbon atom and 5 are in the other. So, positively charged cation and negatively charged anion is formed by the heterolytic cleavage or heterolytic breaking. When writing mechanisms, this is indicated by a curved arrow. You can see it in this diagram. A curved arrow is there to represent the cleavage in mechanisms. Curved arrow is used to demonstrate the atom receiving the 2 electrons. Then we will discuss about the homolytic cleavage. In there, 2 electrons involved in the bond will be equally divided in such a way that 1 electron remain with each atom. For example, carbon-carbon single bond is there and each carbon has 3 electrons belonging to it. When the 2 electrons involved in this bond are equally divided between these 2 atoms, each atom gets an unpaired electron, right? And these 2 atoms become neutral, 4 for each. So then those 2 become neutral atoms. Such neutral species are known as free radicals. We represent them like this: carbon free radical, carbon free radical. 2 free radicals are formed by homolytic cleavage. When writing mechanisms, this is indicated by a pair of fish hooks. I will draw it for you. Here, carbon, carbon. To indicate homolytic cleavage, we are going to draw two fish hooks like this. In mechanisms, we use this way to represent the homolytic cleavage, right? So in homolytic cleavage, two electrons involved in the bond will be equally divided between the two atoms, and this results two neutral species having one unpaired electron. This species is called free radicals, and to write mechanisms, a pair of fish hooks is used. Thank you for being till the end. We will meet in the next video.